It's getting hot, the reaction started. We now have a column of carbon appearing out of the top of this, this beaker.
Sulfuric acid is one of the most common chemicals in the sense that it is made in the largest scale, millions of tons a year.
Okay, so what we're going to do now is we're going to do a couple of experiments with sulfuric acid. So the first one we're going to do is we're going to put some sulfuric acid, dissolve some sulfuric acid into water, which is an exothermic reaction, so we should see it get hot.
Fortunately, I haven't had any major mishaps with sulfuric acid, but like many chemists when they start, I made the mistake of trying to add water to sulfuric acid. If you have concentrated sulfuric acid and you want to dilute it for an experiment, it's very important that you don't put the water into the acid.
So what we have is the sulfuric acid in here. In here we've got some, I've got a pointy stick, it's very good. So we've got some water in here, and this is a thermocouple, so it's going to measure the temperature in the water.
Because when you mix the acid and the water, even though they don't react, you generate a lot of heat because you're forming hydrogen bonds between the acid and the water. And the result is that if you drop the water in the water boils instantly and the acid spits out. And if you're looking closely at the stuff, it spits out onto you. Now, I have had not looking in my face, but I have had this spitting.
Okay, so if we put a little bit in, over here, give it a stir. It's got, there you go. Okay, so already we're reading, so it was set at about 20 degrees when we first started. But if I do it nice and slow-ish, hopefully it won't be too much. Okay, our temperature's now gone up.
So it's really important, if you're trying to dilute concentrated acid, that you take the water and add the acid to the water, gradually making it stronger, rather than taking strong acid and adding the water to try and make it weak.
That's quite a bit. I think we're getting to boiling now. So what have we hit? 97 degrees C, and you can actually see that it's actually starting to boil the water.
I've never actually seen pure sulfuric acid, which is meant to be a really sort of treacly stuff. Treacly means it's very viscous, like syrup of sugar that you sometimes put on your waffles or your bread or cakes. The sulfuric acid we use in the lab is diluted with water. Either very dilute or even concentrated sulfuric acid still has quite a lot of water in it, so it looks pretty runny. The shape of the molecule is quite simple. There is a sulfur atom which has 4 oxygens around it, and on 2 of the oxygens you have a hydrogen atom. So the formula is H2SO4. The formula H2SO4 is one that a lot of people who know nothing about chemistry have heard this formula. Don't know what it means, but it sounds scientific.
It's actually munching through the paper, okay, so it's reacting with the paper, with the kitchen paper. You can see it going, okay. It's pretty potent stuff. It's like burning almost. So we can take this to the next level, something you might have seen before. We can dehydrate sugar.
Sulfuric acid used to be called, in 18th century and before that, oil of vitriol. We still use the expression in English, vitriolic, which means really violent reaction. You know, when you tell the boss that you made a real mistake, the response is vitriolic. The reason for this is that sulfuric acid reacts so easily. One of the reactions is that it can absorb large amounts of water. Even though you've got to the formula H2SO4, it is a very strong dehydrating agent. It can remove water from other compounds.
So what, about 300 sugar, fill up to 500 with sulfuric? We're going to try that one.
If you take a whole range of organic compounds, your body, sugars, most of these have a formula that is approximately CH2O. And if you add the acid to these materials, or you spill it on yourself, what happens is the H2O is abstracted and you're left with black carbon.
So here we have some sugar, common or garden supermarket sugar. And we're going to put the sugar into this, or some sugar into this beaker, add some sulfuric acid and see what happens.
There was a well-known murderer called Haig in London in the early 1950s who murdered his victims. He then drank a cup of their blood, and some people said because the food in the hotel where he lived was so bad. And then he dissolved their bodies in sulfuric acid in the bath. And he was discovered because teeth were found in the drain pipes afterwards.
I've got sugar in your fume cupboard now.
Chemists use sulfuric acid for all sorts of reactions. It is the acid that you use in the batteries in cars.
So what I'm going to do now is I'm going to add some, I should turn it around, shouldn't I? Some concentrated sulfuric acid. Okay, I'm going to try and give it a little bit of a stir, hopefully, as well, to get everything nice and mixed. And pull the fume cupboard sash down, we'll see what happens.
When people are refining oil to make diesel and petrol, gasoline, they remove sulfur from the oil because otherwise it causes atmospheric pollution. So oil refineries end up with large amounts of sulfur, and one of the most economic uses for the sulfur is to turn it into sulfuric acid. So the raw materials are very cheap and the applications are very wide.
It's getting hot, okay? You can see it's getting hot. The reaction started. We now have a column of carbon appearing out of the top of this, this beaker. Wow.
Quite like that.
It's pretty freaky, isn't it? Okay, so you can see the steam coming off of this, okay? This reaction is absolutely boiling hot. Okay, so here, actually I can probably give it a bit of a poke. It's quite hard, actually. So what we've got, basically, is a column of carbon. A column of carbon, because what we've done is the sulfuric acid has dehydrated all of the sugar. So we've just got carbon left.